In this demo, I'll be focusing on network assurance and verification. This is going to include the network map and intent. Starting off with intent, let's go ahead and click into the intent dashboard. Here within the intent dashboard, we can see the various intents that are currently running against our infrastructure, both virtual and physical. You can see the names of the intents. You can see the type of intent, the scope, if there are any alerts, if the status of the intent is passing or failing, the severity level that is defined, and also the notifications that are set for each intent, whether it be SNMP, email, or push notifications. We can also see intents that have been disabled or that are currently running as enabled, and we can delete those, edit those, or copy those intents. Up here in the dashboard, we can see the total number of intents that we have defined in our system. How many of those are failed? 13 network health and 3 device health. How many alerts by category? So we have network health and device health, and alerts by severity. So I've got 77 critical alerts and 38 moderate alerts. Now, let's start off with how you actually configure an intent. First, we're going to go ahead and click on Define Intent. Here you'll see the different intent types that are currently supported within vRealize Network Insight. We have compliance, where you're going to be able to set STIG compliance against password protection. This is going to be for things for like default password existence, plain text password visibility, management connection password protection, console access password protection, and account password protection. We also have device health. This is encompassing HSRP and vRRP active STP root colocation. So this is having to deal with either whether it's proprietary HSRP or vRRP, looking at spanning tree root colocation across those routing devices. We also can set an MT mismatch intent, and we can also look at network health. So network health is going to show us different things. As you can see, many different categories, everything from duplex mismatches to duplicate IPs or MACs, reachability, segmentation, port mode mismatches. There's a long list, and the list continues to grow with each release. Here is where we're going to come in and define those intents. If we are running SD-WAN within our infrastructure, we can also select the SD-WAN analytics and set up intents against our SD-WAN applications or edges or WAN link utilization. Now, a lot of intents will run automatically out of the box within vRealize Network Insight, and then other intents you're going to want to set based off of your definition from a business policy perspective and requirement, such as reachability or segmentation. So if I come over and I select on segmentation, this is going to allow me to choose the segmentation intent. I can provide a name. We'll just call this test. I can select a source segment. I can either do IP address. I can do various different things that I can choose. And you can also hover over the information icon to get different information as to what could be used. So in this case, let's say I wanted to do a segmentation intent against some virtual machines that are running in my infrastructure that I know are traversing also my underlying infrastructure. So here I can come in and I can choose a virtual machine. So we'll choose the front end of my application here, my web tier. And then let's set the backend as my destination segment, which is going to be my database tier. Now, typically, you wouldn't want your web tier talking directly to your database tier in a 3-tier application. Web should be communicating with the application tier, and application should be pulling from the database. Next, we can set our traffic direction. So this is where we can say that the intent is only to look at forward traffic between the source segment and the destination segment, or we can choose bidirectional. I'm going to choose bidirectional, which is pretty standard. We can set the severity level between critical, moderate, warning, and info. I'm going to leave this at default at critical. We can also see the tags. So here I can see network health and segmentation are the tags that have been set. And if you want to add additional tags, you can. You can also come in and choose notes. So within notes, this is where you can actually put in some specific notes so that when the intent does fail or when it's being checked, you can leave notes as to where they should check or what they should do is follow in procedure in regards to like a network admin if this intent was to fail. Then you can also come in and you can choose your notifications. So this is where I'm going to choose my push notification, my email notification, or my SNMP trap. So you can choose on how you want to be notified within the system. And keep in mind, it's also going to alert locally within vRealize Network Insight. Once I've set that intent, I can then come over and I can go ahead and hit submit. So now my intent has been created, and I can see that I have the new intent, which is test for segmentation as the type. And we can see right now it's verifying. Now this will start checking instantly against the digital twin that has been created from vRealize Network Insight as it captures the virtual and the physical infrastructure. All these other intents here, you can see that I've got set up between pass and fail. We can click on any of those to take a look at them and see how they're set up. So as an example, if I click on Cisco MTU mismatch, it's going to show me the intent. It's going to show me what it's looking at, who it's emailing, and so on. And then I can also see any existing alerts. So if I click on the 25 alerts, I can look at all the different alerts of MTU mismatches that have gone off. And these are all left for demo purposes, so 104 days and so on. But these are showing different intents. So these can show a comparison, let's say as an example of a VM NIC that's running only an MTU of 1600 and an Ethernet port that is running on this Nexus 9K. Ethernet 1/32 is running an MTU of 9216. So, technically this would work with NSX, but typically you'd want to have your jumbo frame set to match. So in this case, it's calling out an MTU mismatch. There are some things that you'll see here as an example. Different vendors use different default jumbo frame settings. So as an example, VMware, typically when you enable jumbo frames, it's going to be at 9,000, whereas Cisco is going to be at 9216. You'll even see Arista and so on and other vendors at various different configurations also. So they'll call them out, and then if it's something like in this case where it's just a vendor preferred MTU setting when they enable jumbo frames, I can just come up and I can click on archive, and then I can go ahead and hit save. And now that event has been archived, you can see how it's grayed out. It's still stored for historical purposes for reference. And now I've archived that event. You can also come up here and click actions, and I can edit this event, duplicate, or delete this intent if I wanted to, or disable it. So going back to our intent dashboard, we can see our test intent that we set, and we can see that it is failing. So if we go over and click on our test intent, I can see here that this is a segmentation intent that we chose. I can see the source and the destination segment that I've chosen, which are my web tier VM and my database tier VM of a specific application. And then I can see it's checking bidirectional traffic. Now, from an alerts perspective, we see that it is failing. So what we'll want to do is we'll want to go and take a look at this within the network map to be able to see where this is actually failing at. So next, what I'm going to do is I'm going to go over to the network map. So we'll go back to our home screen here, and then we're going to click on Network Map. Within the network map, here we can see an overview of all the connectivity, both layer 2 and layer 3, of our virtual and physical infrastructure. I've got multiple infrastructures that I'm monitoring, so you can see that I've got a data center here, I've got another group of data centers over here, and I also have another one over here that I'm monitoring that I have all within one single network map. We get that overview of the summary, so we can see the critical, warning, and moderate. We can also see how many switches and how many of those are unhealthy. And keep in mind, those are layer 2 devices, so that's going to be physical layer 2 devices, and also taking into consideration layer 2 segments in the overlay, which are going to be things like your NSXT logical switches. We also have our routers and the health status. So these are going to be physical routers. These are going to be layer 3 switches that are running routing protocol. You're also going to have your NSXT routers, your tier 0 and tier 1s, your firewalls, your load balancers, your transport nodes, and then other entities. And other entities can be things like Cisco UCS, chassis, and so on, as an example. Now we have our legend down here that we can scroll through that shows and represents the different things that we're going to see within the network map. And then we also have over here the capability of toggling alerts on and off within our network map. And to see these, I'm going to go ahead and zoom in some. And here we can see on my physical infrastructure, I can see as an example within my backbone, I can see that I've got my Arista 7050s and I've got some Dell S5248s. And we also have some Nexus 9Ks deployed in this setup. These little red triangles indicate that there are alerts that are active. And these could be analytical alerts, things like packet drop and so on, or they could be intents that are failing. We can also come over and we can click on edit, and this will actually allow us to edit the network map. So you can customize the map to the look and feel that you're comfortable with. Everyone has their own preference from the top down, bottom up, or you just might want to customize it. So you can come over and you can grab a group as an example. This is my F5 load balancer. And as you move it, you can see that it dynamically moves with the connecting switch, in this case, doing my layer 3 routing. Same thing with my PAN firewall. Now you can come over and you can also move devices within a group. So I can come in, I can choose, and you can see as I move it to wherever I want it, it's going to move, and I can place it however I want to position it. Now, when you're first setting up the network map, you can come over and also click on a group. So you click add group, and then you'll give that group a name. So we'll call this test. And then we'll come over and we're going to choose our entities. So these are going to be all the different entities, which are going to be everything from physical hosts to devices such as router, switch, load balancers, and so on. An entity is anything represented in the network map. So you can come in and you can choose multiple devices or multiple hosts, or depending on how you want to group things, like, backbone and so on. And when you choose those entities, you can add a bunch of different entities. And then you can choose the color that you want represented by that group. So you can have your choice of color. I can say, let's go with blue here. And then once I hit submit, it's going to automatically group those devices into that group along with the connectivity. Now, I don't want to change my network map, so I'm just going to hit cancel on this for now. The other thing that you can do is you can click on full screen mode, and this will actually let you have a larger view so that you can edit your network map in a larger view. And you can zoom in and zoom out on that as you're looking at this and having your views as far as layer 2, layer 3 connectivity. So as we can see our ESXi host here and our various edges and so on that are running on, which are basically our virtual routers within NSXT, and also things like our virtual distributed switches running on our host. So we can move these around, we can customize them, and we can see the connectivity to the underlying switches in this case. So this is a layer 3 switch. This Dell S5248 does have all the connectivity to the physical NICs on the host, which are running the overlay devices supporting my virtual infrastructure in this case, or my virtual machines. I'm going to go ahead and click cancel on this. And again, here we can see the network map in the expanded view. You can also see things like in this infrastructure over here, I've actually got Cisco ACI deployed, so you can actually see spine switches, the leaf switches. I can also see my Cisco Fabric interconnects. I can see my FEXs, the blades running in my UCS chassis, and then ESXi running on those blades along with NSXT as the overlay infrastructure. I can also see I have some hosts that are just running standard virtual distributed switches. We'll zoom out. Now I'm going to go back to looking at, I'm going to exit full screen here. Now the other thing that we can do within the network map is we can come in and we can look at alerts. So this is going to pull up all the different alerts that it's seeing, whether it's segmentation failures, reachability failures. We can keep expanding these alerts. We can even search for specific alerts and so on. And you're going to see all the alerts grouped under each one. So the segmentation failure, if I click on it and expand, we can see that this segmentation failure is actually our intent that was called test that we created. And we can see that it's showing us our source segment, which is our web VM to the backend VM. And we can see that the traffic direction is set to bidirectional. Here now we're going to be able to see the different packet headers. So the source IP to the destination IP. And it's actually showing us that in this case, we have unblocked paths, so we're not segmented. Now notice that the source IP is 10.0.2.11, but yet the source segment we set is 10.0.1.11. That is because vRealize Network Insight will go through and check to see if there's any source IPs within the infrastructure, whether virtual or physical, that could be used to spoof the IP address of the source segment. And if that is the case, it'll call it as unsegmented because technically it's not. So we would want to make sure we have proper spoof guard mechanisms running so that these all don't show, or that this intent does not fail and we don't see open possible paths that could be used for different packets. So that is why that intent is failing. Now, we could go ahead and take a look at our paths as an example, and we can come in and we can check that path. So I can say my web front end to my NAV app database. You also can choose advanced options if you wanted to define a source port, destination port, protocol. You can see a long list of various protocols in here and the port numbers for those protocols. You can also come in and take a look at the path type, whether it's primary, backup, or all. Backup's going to be things like ECMP. You also can take a look at the path direction that you're checking or choose. So forward or bidirectional. And then path status that you want to focus on, whether it's all possible paths, meaning that they're reachable or blocked, or you can just focus on reachable or just blocked. I'm going to go ahead and turn this off. You can also add a hop if you want to check via a specific device if there is a hop that can be taken to gain access to that specific database. So you can add in multiple hops if you want to. I'm going to go ahead and close that out. So now we click Show Paths. And here we can see now it's drawing out the paths, and it's showing me the 4 paths, and it's showing me from the web front end, which has that .1.11 IP, to our NAV database 01 backend, which is .3.11, and it's checking any destination port, and it's checking TCP and UDP protocols. Now I can see that there's 4 paths that it found directly between those 2 virtual machines. I can see that 2 of them are going to be what we consider primary paths, and 2 are backup paths. But we can also see they're all labeled blocked. Now over in the network map, and let's go ahead and expand back to full screen for this, a little easier to see. In the network map, we can see our ESXi host for our source, and we can actually see the various different components that are being traversed. So this is going to be our NVDS and NSX. This is going to be my virtual host router. So this is going to be, example, my tier 1 router that is connected to my specific source virtual machine. And then I can see it can utilize connectivity across these Dell S5248 switches that are doing layer 3. So I can see I've got switch 1 and switch 2. These are running in what they call a VLT in the Dell world, which is the same as like a VPC. And then it's showing me the connectivity down to my destination, and my destination tier 1 router that has my destination VM residing on it. Now, you'll notice that this is a dotted line path. This is because the path is blocked. Network Insight will still map out the possible paths, even though it's blocked by an ACL, whether it's in a physical router or a virtual router, or within, let's say, a distributed firewall in NSX. It'll show you the path that can be taken and also show possible path direction. So you can see the arrows here pointing in between these 2 devices, indicating bidirectional traffic. Now, if I want to check any of these, I can just come in and simply click on one of them. And now it's going to focus specifically on that one path. You'll see this line's a little bit whiter and this one's grayed out. And I can also hit Expand All. This is where we're going to be able to see all the detailed information, such as the packet header. You're going to see your source and destination MACs, your IPs, your protocols, what we're starting at, which is our web VM. And then we can see that it's hitting an ACL right away. And it says, if allowed, traffic would continue as follows. And then it will follow through and show you all of the different virtual and physical interfaces in that path as I scroll through here, including all the source and destination information, whether it's using layer 2 forwarding or layer 3 forwarding at each hop, where the packet headers are changing, including which VLANs in the underlay are being used, the physical IP addresses on the host, what port, and we can see this is running NSXT. It's using Geneve, and it's giving me the virtual network identifier and the port number for that specific Geneve tunnel. And then we can see where it's doing encapsulation, and then we can see where it is, again, changing packet header, and it's going in and out, and it hits our Dell S5248 switch in on Ethernet interface 1129:1, and then it's doing layer 2 forwarding and going out Ethernet 1125:1. And then we continue to scroll, and we can see the VM NIC, and as we go back into our ESXi host, we have another ACL in place, and as we continue to scroll down until we reach our destination virtual machine. So we can check this on reverse path and forward path. I also mentioned when we reviewed in the slide deck that we can also click on any of these to look at configuration information. So as an example, I can click on this Ethernet interface, and this is going to pull up the data that we've actually pulled from that device, in this case, the Dell S5248, the packet header, and I can check to see if I have more than one, the command, and I can check to see how many commands are run, and then I can see the data that was actually pulled from that device via SSH read-only in this case. And this is what vRealize Network Insight uses to do calculations using the mathematical algorithms to determine path availability and so on. Now, we can also come over as an example, and let's say I want to see which ACL is actually blocking this traffic. So if I come in and I click on the ACL, it's going to open up. And here I can see that this is a firewall rule that is actually configured on the distributed firewall. And it's telling me here the firewall type. And I can see that it's giving me the sequence ID, my source and destination IP, the service, the action, the rule ID, the NSX manager, the direction, which protocol, both IPv4 and IPv6. And then it's also showing me which ports, section ID, section name, status, again, the manager, and then also the applied to. So this is applied to 3 different logical switches, my app, DB, and web. And then I've got source negate as no and destination negate as no. So as you can see here, this is pretty powerful when you can want to look at specific, what are ACLs that are blocking paths and so on, and which is possibly allowing. And if anything changes, we're going to give that proactive alert letting you know that somebody modified a firewall rule that could impact potential communication between the source and destination. Now, in this case, I do not want communication there. So if this was to change in an action to allow, would be alerted, and I can see who made that change and where they made it within the actual path. The other thing within the network map is entities. So entities is basically everything, as I mentioned, that is inside the network map, various different components, underlay and overlay that is represented. So in this case, we can see there's 706 entities with problems, or I could just click on all entities. Now, I can also come up and I can search for an entity. So if I want to focus on an IP address, the name of a specific device, or let's say I just want to look at by vendor. So I can come in and I can just type in Cisco as an example. And now it's going to show me all of my Cisco devices. So here I can see that I've got UCS blades. I can see my Nexus 9396. I can see my ACI leaf and spines. And if I click on any of these, it's going to go ahead and take me right to that device. So if I click on it, you'll snap to it on the network map, and now I can see the specific device. I can also come over and hit the plus, and it's going to show me each one of the Ethernet interfaces and show me which ones are up and which ones are down. Now, if I wanted to look at a specific interface, I can do that. I can also expand and keep going and looking at the different interfaces that I have here. And I can come over and I can either click on the interface or I can hit show details, and it's going to give me that Ethernet 1/25. And it's going to show me what status it's at, its operational status, its admin status, what VLANs are configured to allow to traverse that specific port, what are the trunk VLANs, the MAC address, the MTU, the interface speed, vendor information, native VLAN tagging. You're going to get a lot of detailed information, as you can see. You can also see the device, the manager, and you can see the peer port that it's connected to in the peer device. Now, in this case, this happens to be an ESXi host on VMNIC2. This is really helpful when you're trying to track paths that specific data is traversing when it comes to VMs and the overlay, traversing the underlay, and which physical ports they're actually utilizing. You can even click on the Ethernet port and dive deeper in to look at deeper analytics for that port, such as things like throughput, packet drop, and so on. So this is going to come up and it's going to show me the switch port. It's going to show me the VMs that are connected to the port and that are utilizing that port. Information, again, about the switch port configuration. I can see if there are any alerts on that specific port. And I can also go to metrics and click on switch port metrics. And here's where I can see information such as network RX rate, TX rate, drop packets on the RX side or the transmit side. And if I also want to add additional metric graphs, I can. And I can also choose different things that I want to focus on. Packets per second as an example. As you can see, many network packet count, We have many different things that we can focus on and click on within the metrics that we want to focus on within the specific port if I was utilizing this from a troubleshooting perspective. Okay, we can also, in the network map, I also wanted to call out, you can also go directly to a device. You can take a look at it by clicking on Entity Details. As an example, I see I've got some alerts on this device, so let's go ahead and click on Entity Details. And as it expands, we're going to see information on this actual 9396 Nexus. Again, information about the OS and what model and vendor. We're also going to see information around switch port tables, what's up, what's down, the MTU configuration, speeds, VLANs that are allowed to traverse those ports from a configuration perspective. Down here is where we can see all of these various different out-of-the-box intents and so on, or intents that we've defined that are running and that have been detected across this specific device. And by clicking on any of these, this is where it's going to show me examples of where I've got misconfigurations or configurations that don't align. So trunk VLAN mismatch, I can see on this Nexus 9K. On Ethernet 2/11, I don't have this configured as a trunk, but on the peer device, which is an Arista 7050, on Ethernet 51/1, I do have trunking set and I've pruned specific VLANs. So this would, be an instance where I want to go in and make a change on that configuration on Ethernet 2/11. We can also see other things like LLDP neighbors being removed, spanning tree cost method inconsistency, link MTU mismatches, and many other intents that are being checked across the device. Once we've fixed or resolved the issue, we can just simply come in and archive that, and that'll clear and store as a historical event. And that is a quick demo on the network assurance and verification feature sets utilizing the network map and intents. I hope you enjoyed that demo, and thank you for watching.